in our question, once we see a triangle, we know it has to do with trigonometry. We know that it is about page 16 in our maths table. So let's have a look. In the diagram below, each of the points A, B, and C represents an airport. Okay, we get that. Airport, airport, airport. The plane traveled 598 kilometers from airport A to airport B. So this distance here, 598 kilometers. And then traveled on to the airport C. So from A to B and then to C. Okay, so what do we need to do? We have to work out the distance AC, correct, to the nearest kilometer. So this is actually the distance we are looking for. Now, triangle, page 16. What I'm looking for is what? Right angle triangle. So here we can see two right angle triangle. We can see, maybe let's get highlighter. So we can see there is one right angle here. So that will be the one we are considering. That will be one of them. Let's just draw that out. And then the second one is here. Oops, is here. And that's my second triangle that I will be considering. Now, what information do we have? That's my A, that's my B, that's B, and that's C. 598. Here I have 280. Here I have an angle of 35. Now, what am I looking for? Actually, for this length plus this length, excuse me, and together that is the length of AC. That's what I'm trying to find. Okay, let's take our page 16, our formula, so that we know what we need to use here. So on that page, we have two options. Let's just, yeah, okay. So we have two options here. We have here Pythagoras, and here we have trigonometric ratio. So how do we make a choice? Which formula do we use? Oh yeah, I forgot that that's as well 280. Okay, so how do we make that choice? So we are saying, okay, Pythagoras trigonometric ratio. For Pythagoras, we have C and then A and B, and what are those? Side, side, side. So I have three sides of triangle. When it comes to trigonometric ratio, each of them have A, and A. And what is that? An angle. So angle. And then it has two small letters, each of them. So that means two sides. So how do we make a choice? So I'm saying, okay, let's consider my first triangle. I'm looking for this part. What is that? A side, isn't it? So I'm saying, okay, I'm looking for a side. So question mark. Now, what information do I have? 598, that is the length. So I have the length. Then I have another length, 280. Oh, here I don't have anywhere to put. So that means Pythagoras has all the option. Is Pythagoras I'm going to use here. Now, I need to know, because since that is the formula, I need to know what is the A, the B, and C in my own triangle. When it comes to Pythagoras, the only reference angle we have is the right angle. And as you can see in your table, that's the right angle, and the side opposite is C. So that means since this is our right angle, the side opposite is 598, so that will be my C. Now for Pythagoras, because we add up A and B here, doesn't matter which side we're going to pick to be A and which side we're going to be B. So let's say the one I'm looking for is A, the one I have is B. Okay. So we replace letters with numbers. So instead of C, we have 598. Now that is taken to the power of 2. Then I have equal. Then A. My A is what I'm looking for. So let's leave it as A plus. And then my B is 280. And again, let's not forget about power of 2. Okay. So where am I going with my calculation? Well, I want to have this A on its own. So how do I get rid of this number? Well, we take it to the other side of the equation so that it joins the other number. So this side of the equation, I have 598 to the power of 2. When I move a number from one side of the equation to the other side, what happens? It changes the sign to the opposite. So positive becomes negative. Okay, so now I'm almost there. excuse me, I want to have a, not a to the power of 2. How do we get rid of that power of 2? We take a square root of the other side. And then we put all of that in our calculator and get the answer. Or we wait till, because let's not forget that's part of our calculation. So if I take this value, 598 to the power of 2 minus 280 to the power of 2 under the square root plus, now let's figure out how do we find the value of this part here. So again, now let's just remove our drawing because we have to consider it again. Is it Pythagoras or is it trigonometric ratio we're going to use? So Pythagoras, 3 sides, trigonometric ratio, an angle, and 2 sides. So let's see. What am I looking for? This side. So I am looking for a side, question mark, don't have it, need to find. I have 280. That is a side, tick, tick, have it. And then I have an angle of 35. Okay, so Pythagoras doesn't have enough information, therefore I know it's going to be trigonometric ratio. But which one of them? Sine, cos, or tan? Well, again, what we do, we put those letters from the triangle in our table to our own triangle. So again, where do I start? Angle. So my angle here that is given to me is here, so that becomes my capital A. And again, the principle the same. The side that is opposite is A. So the side that is opposite that will be 280, so that's my A. The next angle, the reference angle, is the right angle. The side opposite is C. That's where we have the right angle, therefore the side opposite is this one, that is C. So that means that the remaining one is B. Now, what do I need in my formula? Well, I am looking for B, so my formula has to have small b. I have small a, so my formula should have small a, and I have capital A. There is no point of me to choose a formula with C. I do not have C. So I'm saying, which one of them have those 3 elements? Have a look. Yes, and you're right, is tan. Tan is the one have capital A, small b. That's my formula. So we write our formula, tan of A will equal A over B. And now let's replace again letters with numbers from our question. So it is tan, angle is what? 35, equal fraction line. On top of the fraction I have A, my A is 280. At the bottom of the fraction I have B. I don't have B, so I'm just going to leave that as B. So how do I find this B here? Now, the problem is at the bottom of the fraction. So what do I do with it? Well, if I have this type of an equation where I have a number here, and then I have a fraction on the other side, those two values can change places. How come? Well, it's like with the numbers, if you think about it. If I have 6 and I divide that 6 by 2, the outcome of that will be 3, isn't it? The same way, if I have 6 and I divide it by 3, the outcome of that will be 2. So that's what I'm saying, those two can change place. So that means I can write B equal 280 divided, now we can put the tan of 35 here. Okay, and then again, we can put that in the calculator and get the answer. Or don't forget, we have this length, that's our length, plus, and now we found this length, so let's add it up. Plus 280 divided by tan of 35. Yes, you can do that because our answer is the length of AC. And then we can put all of that in your calculator, press equal, and to the nearest kilometer, we should get 928 kilometers. That's the value we should get. So again, can't stress it enough. Trigonometric ratio, Pythagoras, that page 16, extremely important in our junior cert and very, very important as well in our leaving cert. So please make sure to really, really get into it.